Guys, in this video we are going to deal with the electrophilic substitution reactions of carbonyl compounds and certain uses of your aldehydes and ketones. I hope so this video will be short because only two concepts have to be undertaken in this video. So in our next video we will be seeing with respect to that of your carboxylic acid. But remember, this video will be somewhat interesting part. Why I'm saying so? You will come to know when I give the concept-wise explanation. So as I mentioned, today we are going to deal with electrophilic substitution reaction of carbonyl group. Or you can just say electrophilic substitution reactions of our carbonyl compound. Yes. So why I'm saying it as an interesting. So before to get to know what is the interesting fact, let me ask you a question. What is that? Of course, we have read the electrophilic substitution reaction of haloarenes. Yes or no? Similarly, we have read about the electrophilic substitution reactions of alcohols. Similarly, we have read the electrophilic substitution reactions of ethers. Till now, whatever we have learned so far in our organic chemistry, in each and every chapter, concept was same. Yes, electrophilic substitution reaction. So let's have a quick recap of what are the products we were obtaining. So you should answer me, okay? So yes, so this is my I think it's a chlorobenzene. Let us nitrate it, that is in the presence of concentrated HNO3 and that of your concentrated H2SO4 alva. Nitration ಮಾಡಬೇಕು ಅಂದ್ರೆ we have to use both the acids. So ಯಾವ electrophile ಇಲ್ಲಿ generate ಆಗುತ್ತೆ? Of course your NO2+. So what will be your product? Since it is an electrophilic substitution reactions of haloarenes, what will be your product, guys? Yes, so one will be your ortho substituted chlorobenzene and another will be our para substituted chlorobenzene. Yes or no? Yes. So what is the major task? This is an electrophilic substitution reactions of chlorobenzene. Let me go with phenol now. So I'm just changing my reactants, okay? But I'm doing the nitration in all the cases. So OH. So here I will be using my concentrated HNO3 in the presence of concentrated H2SO4. What will be the product now? Yes, so here you will be getting as an orthonitrophenol plus paranitrophenol. Yes or no? Paranitrophenol. Let me go with my ethers. So here I would be using my OCH3. Yes, plus concentrated HNO3 in the presence of concentrated H2SO4. Same nitration, just in the three cases I have used haloarenes, phenols and ethers. That's the concept. So of course here also we have got as what? Orthonitroanisole, NO2, orthonitroanisole plus paranitroanisole. Yes or no? Of course, we have dealt with all of this. Of course, these are the reactions which we have studied under electrophilic substitution reactions of their respective chapters. Alva. But why did I say when we are studying the electrophilic substitution reactions of carbonyl compound, it is somewhat interesting. Of course, a question mark arises. It is because, for example, if I am going to use my benzaldehyde, what I am going to use? My benzaldehyde. C6H5CH2. Same if I am going to do it with a nitration, concentrated HNO3 in the presence of concentrated H2SO4 nitration mixture. So what I am getting over here is the interesting fact. I am going to get metanitrobenzaldehyde. Mark my words, metanitrobenzaldehyde. Able to understand? That is the reason I have just wrote all the reactions what we have studied so far. You have to just compare it with your earlier electrophilic substitution reactions. So with respect to the haloarenes also we have got an orthopara. With respect to phenols, we have got orthopara. With respect to the ethers, we have got an orthopara products. But when we are talking about our benzaldehyde, that is your carbonyl compounds, your aldehydes or ketones, there we are getting a meta-substituted product. Of course, in all the cases, we are doing an electrophile substitution itself. Electrophile is your nitrate ion. Then why is this such a drastic change is observed? The question lies with respect to the group which is attached to our benzene ring. Alva. So as I mentioned in my earlier classes, here the chlorine group, whatever is present, it is what it is acting as. It is acting as a ring activator. Ring activator andre. This group is supplying the electrons to the benzene ring. So when it supplies this, for example, if I write the resonance hybrid directly for these structures, so I'm just writing the resonance hybrid overall structure. Okay. So there we are observing that. So in the ortho and the para positions, we were having the negative charges. That is, the electron density were higher. Why? Because here chlorine group is acting as a ring activator. Ring activating groups and which has the capacity to donate the electrons. Alva, do remember. Again, incoming was an electrophile, which is a positively charged species. Of course, it was going and attacking in the ortho and the para position. The same concept was with respect to the phenol. Yes, it is also was an ring activating groups. Alva, ring activating groups. I am writing the resonance, overall resonance hybrid structure. Here also we are observing the same thing. In the ortho and the para positions, we are having the high electron density. Same was the case when I was treating with my ethers, that is your anisole, for example, OCH3. When I am writing over here the resonance hybrid, I am going to get in this way: delta minus, delta minus, delta minus. So of course, what is it indicating? It may be your haloarenes, it may be your phenols, it may be your ethers. So in all the cases, whatever the substituents were there, which has been attached to the benzene ring, they were all ring activators. They are what? Ring activators. Or they were the ortho-para directing groups. Remember, ring activators, or we can also call them as what? Ortho-para directing groups. Ortho-para directing groups. The only reason was they were all having the capacity to donate the electrons. But the question is somewhat different when we are talking about our carbonyl compounds. When I am taking an example of benzaldehyde, why I am getting a meta over here? Of course, I think some of the pupils may have come to know that. Why is it so? Yes, if your answer is your aldehyde group or your carbonyl group is an electron withdrawing group. I repeat, electron withdrawing group. So it acts as a ring deactivator. What are you understanding? It acts as a ring deactivator, and therefore it will be a meta-directing group. Confusing? Don't worry. We will deal with its resonance structures. So let me write first of all my benzaldehyde. Okay. So like this. Yes. First I have written my benzaldehyde. Of course, now what happens? Due to the high electronegativity difference between our carbon and the oxygen, what will happen? This electrons will be oriented towards your oxygen. So carbon will get a positive charge. So what it will try to do now? This electrons will be shifted over here. Yes. So the resonance structures I'm going to write. Please note it. See the signs which will be coming in the ortho and the para position. Okay, now here you'll be having a double bond character. C, O has taken an electron, so minus and a H. So illig hoitu. E carbon madhyadalli E double bond was existing ala. On this carbon and this carbon in between we are having a double bond. Now this double bond has gone over here. Of course, the valency of this carbon is satisfied. But what about the valency over here? It has been decreased. So here it will be getting now delta plus. Yes, as usual, here there is a bond, here there is a bond. Yes or no? So now in order to balance this, okay, let me write it as a plus itself. Okay, plus. So now what will happen in order to balance the valency over here? This pi electrons will move over here. Okay, so when it is moving over here, what does it mean? Yes, so now we can write the structures in this way. So here now there was a bond. Yes, now this bond has moved over here. So here comes a bond. So what happened to this carbon? The valency has been decreased. So here also you're getting a positive sign. Here also you're getting a positive sign. And of course, because of the group of your aldehyde group. Yes, it doesn't stop now there. In order to balance this valency, this will come down. So now what will happen? So I can write in this way. So double bond CO minus and a H. So here and a here. Yes. And now here I will be having a positive sign. Yes or no? So in order to balance that one out, this would be given. Yes. So this would be given over here. So the final structure I can write is in this way. That is C double bond O and a H. So here the bonds will be there. So overall this resonance structures can be given in a resonance hybrid anta heltivi. The actual structure, ಈಗ ಎಲ್ಲಾ ಸ್ಟ್ರಕ್ಚರ್ ಇಂದ ಸೇರಿ ಒಂದು ಕಾಂಪೌಂಡ್ ಯಾವ ತರ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನೇ ನಾವು resonance hybrid ಅಂತ ಹೇಳೋದು. So a resonance hybrid, how it would be? It would be in this way. That is C double bond O and a H is there. Now here as usual we have seen the pi electrons are rotating. Yes, but along with the rotation we have also observed here you are having a delta plus. Here you are having a delta plus. Here we are having a delta plus. So now this is the actual structure of your benzaldehyde. So what it is indicating, if in case we are taking a benzaldehyde structure, that compound is having a positive charges on ortho and the para position. I repeat, ortho and para positions, your benzaldehyde is having a positively charged. So of course if I am going to do an electrophilic substitution reaction, that means what? Electrophile means positively charged species. Yes or no? Positively charged species. So now where it should go and attack? Of course positive will be repelled by the positive. So the only tendency for an electrophile to go and attach to a benzaldehyde is the electron rich center, that is your meta position. That is your meta position. So that is the reason, guys. That is the reason whenever we are treating our benzaldehyde with a nitration mixture, that is in the presence of HNO3 and concentrated H2SO4, temperature range of nearly 273 to 283 Kelvin. So what is the product you may get? Of course we would be getting meta-nitrobenzaldehyde. What will be getting? Meta-nitrobenzaldehyde. Why we are getting the meta? Because in the ortho and the para position, it is having an less electron density. That is, it is having a positively charged. So it will be repelling your electrophile. The only position where it is available with a rich electron density is the meta position. So therefore we say carbonyl group, remember, mark my words, important point. Carbonyl group, yes, is a meta-directing group, is a meta-directing group, or what we can say, deactivating group. Ring deactivator, we can say, ring deactivating group. Yes. So now we can understand, I hope. So whenever a ring deactivator group is present, the incoming electrophile, mark my words, I am talking about an electrophile, not a nucleophile. We are talking about electrophile. Yes. The incoming electrophile will be obtaining a position at the meta. Whereas if in case if you are having a ring activators, that is electron donating, yes, electron donating, the incoming electrophile will be giving you the ortho and the para substituted products. So why I'm saying it in a detail? So when in your exams, in competitive exams or even in your board exam, they can ask you, by giving like the structures. OCH3 is there. You are treating it with concentrated HNO3 and H2SO4 at nearly 273 to 283 Kelvin. Identify A. This will be your A. Okay. And B. They can give you as what? Benzaldehyde. Yes. In the presence of concentrated HNO3 and H2SO4, 273 to 283 Kelvin, identify A. So you should remember what? Ethers, haloarenes, or even of phenols. So they are all what? Ortho-para directing groups for your electrophile. So here what you will be getting? Here we would be getting two products. Even though they are given as A, you have to write both the products. Okay. So here you will be getting as what? OCH3, NO2 in the ortho position plus OCH3, NO2 in the para position. Yes or no? Mark my words, O is bonded to your benzene, N is bonded to your benzene. But when we're talking about your benzaldehyde, what is this giving you? Meta-nitrobenzaldehyde. Meta-nitrobenzaldehyde. So you should not get confused. The only concept lies what type of a group which has been attached to the benzene ring. If it is an electron donating group, it acts as a ring activator and it increases the electron density in the ortho and the para position. If it is a ring deactivator, it will be a meta-directing group which will be having the higher electron density in the meta position. Okay, and do remember till now whatever we were talking, it is with respect to the electrophilic substitution reaction. I repeat, electrophilic substitution reaction. Again and again I am indicating. Okay, I am talking about electrophile, positively charged species. Is that clear? Very much important. So okay, I hope so there is no doubt with respect to over here. So in today's concept we had deal with the most important and interesting thing about a carbonyl compound, that is your electrophilic substitution reaction. And we came to know that that interesting factor is whenever we are carrying out an electrophilic substitution reactions of our carbonyl compounds, it is mainly going to attack in the meta position. In the meta position. Why is it so? Because your carbonyl group is acting as a ring deactivator. So that is the reason it is having the less electron density, or we can say positively charged at the ortho and para position, which is going to repel the incoming electrophile. Whereas in the meta position, the electron density is higher, so therefore the electrophile can easily attack your meta position. Is that clear? Very much important. So you have to relate in this way. Now we study madidwala. See, we were talking about aldehydes, but also I have dragged the reaction from alcohols, phenols and ethers. Yes or no? And also from halogens. So by this way when you study, you'll come to know that what is the main differences we have studied so far. What are the importance of the groups? Which are the electron withdrawing groups? Which are the electron donating groups? If electron donating groups are there, where does the electrophile will come and attach? If an electron withdrawing groups are there, where does your electrophile go and attach? So by this way you have to study your organic chemistry. So all the chapters are interconnected. I repeat, all the chapters are interconnected, so you should be much aware. If you are studying a concept, try to glance whether we have studied the same concept in our earlier chapters. So it will be a revision for you. Is that clear, guys? Okay. So next concept will be going with respect to the uses. Uses of certain important aldehyde compounds and certain important ketonic compounds. Okay. So guys, let us see certain uses of our aldehydes and the ketonic compounds. Though in my notes I have given you some little concepts of the uses, since we are doing this video since this is the last concept of our aldehydes and ketones, I would be just giving you certain external information. Okay, some extra information. Okay. So first of all, I would like to go with the uses of our most important compound, which is called as formaldehyde. Formaldehyde, HCHO, very much important. Why I'm saying it is an important, because whatever the biological specimens you are seeing, alva, or your anatomical specimens, whatever we have seen which has been preserved in the bottles, of course you can just observe that it will be preserved in somewhat of a liquid. Yes or no? That liquid is actually called as a formalin. Actually what it is called as formalin. Formalin. Basically this formalin is what? It is actually 40% aqueous solution of formaldehyde. 40% aqueous solution of formaldehyde. So basically this formalin is mainly used for the preservation of your biological and your anatomical specimens. Is that clear? One of the best use we have seen in our day-to-day life. Okay. Why it is used as a preservative? Your question is, remember, when we add this formalin, okay, when we are adding this formalin, it makes the tissues hard. It makes the tissues hard. So once the tissues get hard, of course, it could be preserved. It could be preserved. So that is the reason we are mainly using this formalin as a preservative for our biological and anatomical specimen. Similarly, this formaldehyde is also an antibacterial agent. Okay, it can also be used as an antibacterial, and also it can be used as a disinfectant. Disinfectant. And also for tanning in the leather industry. Tanning in leather industry. Okay, but one of my favorite was it was used in the manufacture of your RDX, in the preparation of RDX. Yeah, the same RDX which we say as one of the, what you can say, explosives, one of the dangerous explosive. So in the preparation of RDX also this formaldehyde has played a vital role. Okay, actually how we are preparing it means by the nitration of urotropin. Okay, so even the compound what we are doing is actually what you can say amine compound. So iduna now nitration ಮಾಡಿದಾಗ basically we will be getting our RDX. But one of the, why I said this was one of my favorite, because this urotropin, what is there alba, this is actually an antiseptic. What it is? It is actually an urinary antiseptic. Urinary antiseptic. Can you see? A medicine can be turned into an explosive just by one group, that is also by nitration. If you want this urotropin in its IUPAC name, I hope it is hexamethylene tetraamine. Yeah, hexamethylene tetraamine. So this urotropin is actually hexamethylene tetraamine. So when you are doing the nitration for this, you will be getting our RDX. Getting to know. But the interesting fact is, whatever the nitration you are taking is actually a medicine or a drug, we can say, which is used for a urinary antiseptic. Okay. Similarly, this formaldehyde can be used for making mirrors. Yes. Heng mardira formaldehyde in the mirror. So yes, the same tolerance test. Tolerance reagent na use madkondo we can make mirrors. For making mirrors also they have been used by using our tolerance reagent. Okay, as I mentioned, it's also used in the preparation of your urotropin, which is an antiseptic, urinary antiseptic. Similarly, one of the most important, and you will be seeing in your polymers lesson, okay, it is also used in the manufacture of your important polymer called as a bakelite. Bakelite, okay, actually is a condensation polymer. You'll be studying it in detail. There once again we'll be studying about its reaction. There you will be seeing that the important reactant for the manufacture of this polymer, which is called as a bakelite, we would be requiring our formaldehyde. Is that clear? So these are the certain uses. Okay, first and the foremost use was with respect to the formalin, which is actually a 40% aqueous solution of your formaldehyde. Please mark my words. Very much important about this formalin. 40% aqueous solution of formaldehyde. It is used as an antibacterial. It is used as a disinfectant. And also it is also used for sterilizing your biological instruments. Yes. And also in the manufacture, or I cannot say as a manufacturing, in the preparation of RDX. Yes, RDX by the nitration of urotropin. Okay. Then in the preparation of your urotropin itself, which is an urinary antiseptic. Okay. And also in the preparation, most important is in the preparation of our bakelite, in the production of the bakelite, which is actually a condensation polymer, and there we will be using our phenol and formaldehyde. The major reactants are phenol and formaldehyde. You'll be studying it in detail in your polymers lesson. Okay, so these are certain uses of what? Formaldehyde. Coming to another use, that is of your benzaldehyde. Benzaldehyde, yeah, the same benzaldehyde which we have studied in electrophilic substitution reaction. You know the formula C6H5CHO. Basically, it's used when we're talking, it can be used as a flavoring agent. Flavoring, flavoring agent, yes. And also it is also used in the important synthesis of cinnamaldehyde. 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 Cinnamaldehyde and your cinnamic acid. Cinnamic acid. Okay. As a flavoring agent in the manufacture of your cinnamaldehyde and cinnamic acid. As I have mentioned, your higher aldehydes and ketones can be used. They will be having a good odor, so they can be used in a perfume industry. So in perfume industry also, benzaldehyde has its own applications. Okay, and in the manufacture of one of the important dyes. Dyes means that it's a coloring agent, guys. Coloring agent, which you'll be seeing in your higher classes. Okay, I don't want to deal with it now itself. It's a coloring agent. Dyes anta heladu. For example, your jeans pant, whatever you are wearing. Okay, it is whatever the blue color is there, that is a dye. That is a dye, indigo dye. So aduna kuda prepare ಮಾಡ್ತೀವಿ ನಾವು lab ಅಲ್ಲಿ. Okay, such a one dye is there which is called as a malachite green. So ಆ ತರ ಒಂದು dye ನ manufacturing ಮಾಡಕ್ಕೆ ಕೂಡ benzaldehyde plays a vital role. So in the manufacture of dyes, which is called as what? Malachite green. One of the dye called as what? Malachite green. Okay. So these are certain uses of benzaldehyde, used as a flavoring agent in the preparation of cinnamaldehyde and cinnamic acid, in the manufacture of your perfumes, in the manufacture of your dyes like your malachite green. Coming with respect to your acetophenone. Yeah, acetophenone. You know, formula acetophenone though, very much important. C6H5COCH3. Yes or no? C6H5COCH3. Why it is important? Because first and the foremost thing, it is very much important because it will be liked by certain students. I don't know, whenever you will be studying, you will be getting the sleepness, alva. I don't know whether it will be synthesis in your body or not, but remember, this acetophenone is actually used as a drug, which is called a sleep-inducing drug. Sleep-inducing drug. But our students will not be requiring. If you just read this chemistry lesson, I hope so many of you will be getting the sleep. Okay. Acetophenone is actually a sleep-inducing drug, which is given by the name, the drug name is hypnone. Hypnone. The sleep-inducing drug, whatever we are using, it is actually called as hypnotic. Hypnotic drug antanu heltivi. Hypnotic drug andre which induces sleep. Who will not get a sleep, they can use this drug. Okay. Under the precautions of your doctors. Okay, don't take it directly, that's another case. But acetophenone can be used as a sleep-inducing drug under the name concept what? Hypnone. So that now manufacture ಮಾಡಬೇಕು a drug na. If you have to manufacture this drug, we will be using the major reactant as acetophenone. And as usual in perfume industry, this acetophenone will be used. But a major important thing I would like just to recall, one of my interesting fact of acetophenone is, of course, we have seen tear gas. The same tear gas where the police will be used to disperse the mob. The curfew strike, if that is becoming very, very violent, in certain cases, they will be using tear gas. Okay. The tear gas na manufacture madakke kuda, this acetophenone is very much important. Why? Because one of the major component of your tear gas is your phenacyl chloride. So this is actually being a what? Lacrimator anta heltivi. LACHRYMATOR. Lacrimator means nothing which irritates our eyes. Okay, this part is irrelevant. This irritates our eyes, and finally it will just, what you can say, tears comes out. Okay, it will just induce the tears to come out, making our skin to irritate much. So if phenacyl chloride actually manufacture, we have to do means we have to use our acetophenone. Why I'm saying so, if you just see structure, you'll come to know. Of course, this will be the structure COCH2Cl, where one of the hydrogen will be replaced by your chlorine. So iduna compound prepare madake acetophenone is utilized. So tear gas ali one of the major component which causes the tears in our eyes, which is a eye irritant, is your phenacyl chloride, which is used by the policemen or by the fire extinguishers to disperse the mobs. You have seen in many cases that is called as a tear gas. So you can just see that what are the major uses. Alva ondalli nodre RDX prepare ಮಾಡಬಹುದು, ಇನ್ನೊಂದರಲ್ಲಿ ನೋಡಿ ನಾವು tear gas na prepare ಮಾಡಬಹುದು. If you say the other phase, we can also synthesize the drugs. Yes. So chemistry has its own benefits and disadvantages. So you have to utilize it in a better way for better understanding and for the betterment of the life. Coming with respect to the other carbonyl compounds, I would just like to recall of acetone. Acetone, if I use, one of the, we can say acetone is a good solvent. One of it is used as a major solvent. Yake? Because many of the organic compounds will be taken or will be just being recrystallized using your acetone itself, because acetone is a volatile one. As soon as you keep it in a beaker or you be keeping your bottle open, it will just evaporates out, leaving back your compound as it is. So that is the reason it is used as a good solvent. Similarly, it is used in the manufacture of your alcohols, that is your 2-methyl-propanol, one of the major use it is having industrial application only. Okay. Coming with respect to another aldehyde I have missed, that is your ethanol, acetaldehyde, I hope. Ethanol is called as what? Acetaldehyde. Acetaldehyde, basically its uses in the manufacture of acetic acid, in the manufacture of chloroform, yes. Similarly, in the manufacture of your polymers and in the manufacture of your drugs, this ethanol is having its wide applications. Is that clear? So these are the certain uses of our carbonyl compounds, which includes our benzaldehyde, which includes our formaldehyde, which includes our acetaldehyde. Similarly, we have seen certain ketonic compounds also, which includes your acetophenone and acetone. Okay. So I hope so this completes our today's video, where we have dealt with the two important concepts. One is the electrophilic substitution reactions of the carbonyl group, and other are the uses of our carbonyl compounds. Is that clear? I hope there is no doubt. And be aware, in next video, we will be seeing an important concept about our remaining part, that is carboxylic acids. Yeah, interesting and very important chapter. In this chapter itself, we will be seeing, because actually the chapter is aldehydes, ketones and carboxylic acids. So till now, whatever we have dealt was aldehydes and ketones. So in my next video, we will be having a knowledge about carboxylic acids. Why it has got as a carboxylic itself, we'll come to know. What are its reactions? How can we manufacture it? Whether it is similar to that of your ketones and aldehydes. Such questions will be easily answered once we deal with it in our next video. Okay. Till then, have a knowledge of your electrophilic substitution reactions of carbonyl group. Once again, I am reminding, it is a ring deactivator, and the incoming electrophile will attack in the meta position. Is that clear? Okay.